Okay, so today we are going to be talking about inductive and deductive reasoning and how we use those to make conclusions. Okay? So the first thing you need to know is what inductive reasoning is and what deductive reasoning is and what the difference is. So inductive reasoning is looking at data, recognizing patterns, and then making a generalization from what you observed or from what you saw. Deductive reasoning uses facts, definitions, properties, and the laws of logic to form a logical argument. And then you work kind of towards the data. So this one, inductive reasoning is like when you look at a pattern and find like the next couple pieces in the pattern. And deductive is when you use things you know to be true and then kind of form an argument based on those. Okay, pause the video right now, please, and try to fill in the next missing term in each sequence. Here are the terms. Actually, no, apparently not. I need my pen. Okay. Here are the terms. Once you're done and you've paused, these are what you should get. Okay, so you're just looking at the patterns and figuring out the next piece. So this is the missing pieces. Okay, now we're going to make a conjecture about the sum of the first 20 odd numbers. So here is a hint to get started. Please pause your video right now and try to figure out what the sum of the first 20 odd numbers would be. Okay, so now once you've unpaused, if you fill these in, you would notice maybe that these are all square numbers. So 1 is equal to 1 squared, 4 is equal to 2 squared, and 3 is equal to 3 squared, and 16 is equal to 4 squared. Okay, so if it's the first 20 odd numbers, then we can assume also that that would be 20 squared. So we're looking at that pattern. So we know that the sum would be 400. So for this next section, we're going to talk about counterexamples. And so counterexamples are something that proves that it is not true. So we're going to look at each statement and find something that doesn't fit. Okay, so for the first one, it says if a number is divisible by 5, then it is divisible by 10. So we want to find something that's divisible by 5 and not divisible by 10, because that would be a counterexample. That would say, yeah, you can't necessarily assume that this statement is true. Okay, so I'm going to pick 25, because 25 is divisible by 5. But not 10. So this is the counterexample, and it proves that it is not true. Okay? Then the next one is you can connect any 3 points to form a triangle. So I'm looking for 3 points I cannot connect to form a triangle. And so the 3 points that I cannot connect are going to be 3 collinear points. So 3 collinear points do not form a triangle. Okay? And then the last thing would be if you slice a pizza using only straight cuts, then the number of pieces will be twice the number of cuts. So we're looking for something that makes that not true. And the counterexample I'm going to use here is if I cut this pizza twice like this, then there's 1, 2, 3 pieces. So, and the number of cuts, so 2 is the number of cuts, that has an E at the end, and 3 is not 2 times 2, or twice the number of cuts, okay? So it's not double that. So that's our counterexample. So again, counterexamples are something that prove the statement to be incorrect. Okay? So if you've ever seen Monty Python and the Holy Grail, it's a great movie. I would highly recommend it. But they use some very flawed logic, but we're going to use their logic right now. And we're going to talk about some witches. And if you have the chance, or you could pause this and watch on YouTube the Monty Python, and you could just look up "The Witch Weighs as Much as a Duck," and it's a great little clip. I would highly recommend it. But that's what we're using here. So we're saying that the logic being used by these guys is accusing someone of being a witch, and they're saying that all these witches in here, they weigh as much as a duck. Okay, so we're going to write a conditional statement to describe this diagram. And so the conditional statement, which is an if-then statement, okay? So an if-then statement would be if it is a witch, then it weighs as much as a duck. Okay, so if it's a witch, then it weighs as much as a duck, and that describes this diagram here. Okay, so using that statement, if someone is a witch, we can conclude that they are a duck. Okay, and that's called the law of detachment. So if I say Miss Bab is a witch, then we can conclude that she weighs as much as a duck. Okay, so if the hypothesis is true, then the conclusion is true as well, and that's what we call the law of detachment. So we're going to practice that real quick here. So here's a conditional statement. If something is made of wood, then it floats on water. Okay, and so then I read the statement that says, my boat is made of wood. Well, that was the hypothesis part, and so we can then assume that the conclusion is true as well. So my boat floats on water. So we're just using this piece of the statement because we already saw the beginning there. Okay? And use the same idea here. If M is the midpoint of a segment, then it divides the segment into two congruent segments. And then we say M is the midpoint of AB. I'm sorry, you guys. I'm trying to scroll down and get this little box out of the way, and it's not working. There we go. Okay, so M is the midpoint of AB. So M is the midpoint of a segment. So then we want to use this part to write our conclusion using the law of detachment. So we're going to say that M divides AB into two congruent segments. So we're taking these in general, the its and the segment, and replacing it with M and AB, because that's the specific statement using that law of detachment. Okay? So now we're going to talk about the law of syllogism. So what the law of syllogism does is it takes two conditional statements and puts them together, and then we can create a third conclusion, a conditional statement. So we're going to take the two statements of if she is a witch, then she weighs as much as a duck. And if she weighs as much as a duck, then she floats on water. And we're going to turn those into one. And so the law of syllogism says that if the conclusion and the hypothesis are the same, then you can take these two pieces and turn them into a new conditional statement. So if she is a witch, then she floats on water. Okay, and that's called the law of syllogism. So if they're both true statements, then you can use the first hypothesis and come to the second conclusion. Okay, so the first hypothesis, if she is a witch, and the second conclusion, then she floats on water. And you put those together and you come up with a new statement. Okay, so then we're going to use that here. And so I actually like to just cross out. So the first conclusion and the second hypothesis, if they're the same. So if a number is prime, then it does not have repeated factors. If a number does not have repeated factors, then it is not a perfect square. So I see that this conclusion and this hypothesis are the same, so I can remove them and use the first hypothesis here and the second conclusion and write a new statement. If a number is prime, then it is not a perfect square. Okay, I'm going to do one more example of that. If a number ends in 0, then it is divisible by 10. If a number is divisible by 10, then it is divisible by 5. So again, I see that first conclusion and the second hypothesis are the same. So I'm going to rewrite, omitting those, and just taking this first hypothesis and the second conclusion and rewriting a new statement. If a number ends in 0, then it is divisible by 5. Okay? So, today's lesson was a lot just about logic and coming to logical arguments using inductive and deductive reasoning, as well as the law of detachment and the law of syllogism. Okay? So, today for your assignment, there's going to be a formative on inductive and deductive reasoning. And when you go to type in your answers here, make sure that you put just one space in between all your words. I know that seems silly, but because it is on formative, if it doesn't match, that could be why. So just make sure you type it in correctly when you're typing in sentences. Okay? Please let me know if you have questions.